Alright. Every once in a while you just have to hit record and see what happens. I think that's today's video. We're going to talk about translations, which are a particular, one moment. They're a particular type of rigid transformation. You see, every time I say the word rigid transformation, you got to say the words preserve, size, and shape. So I'll try it. Rigid transformation. Rigid transformation preserves size and shape. Okay, so we're going to talk today about one particular rigid transformation called a translation. Okay, so a translation, I have one up here. I have the pre-image, which is before the translation, and I got the image, which is after the translation. And so as you can see, I cut out this, there we go, and there's the image. So one thing you notice is that they are the exact same size and shape because it's a rigid transformation, and rigid transformations preserve size and shape. So that's one of the first things we want to notice about a translation. All right. So what's the question? We're gonna go over two examples. The type of question I'm going to talk about right now, I drew this little diagram here for you. So when it comes to transformations, we have essentially the pre-image, the image, and then we have the mathematical transformation. What's the operation we perform on this pre-image? And in math, of course, you're going to be given two of them, and you need to find the third. And so today, these questions, you're going to know the pre-image, you're going to know the image, and you're going to be asked to describe what's the transformation. Okay? So I have one drawn here. So we have a pre-image, we have an image. I'm just going to tell you it's a translation. I mean, even if you didn't know, you could figure it out, but I'm just going to say the question is, describe the translation that maps this pre-image onto this image. I know it's probably hard for you to see the coordinates, but that's why I wrote them here and here. So here's the coordinates of A, B, and C. Here's the coordinates of A prime, B prime, and C prime. So for the image, we throw the little prime spot down there. We hit it with the little prime. So let's start to talk about how are we going to describe this, because that's the question, First thing I'm going to do is I'm going to draw a vector that connects each point. So a vector is this mathematical quantity that has a size and it also has a direction. And so you put a little arrow. The arrow implies the direction. It doesn't imply that it goes on forever. It just implies direction. Okay, and so now I'm going to go here. So those are vectors for the 3 points A, B, and C. One thing you could notice, it might be nice, if this was a class, I would pause and ask you, what do you notice, what do you wonder? But in this case, I'm just going to tell you, they're all the same length. That's one thing you could notice, and they are all parallel. So that's the hallmark of a translation, is that the vector that maps the image, a point on the pre-image to a point on the image, that is parallel and the exact same length for any point, doesn't matter. That's how you know you're dealing with a translation. So now really the goal is how do you communicate this green line? How do you communicate this vector? That's describing the transformation. Because really every point just flows along this vector. So think of point A as just a little point there on the edge. What we do is the whole thing goes and we're there. Okay, so we got to describe that. One way of doing it is by the x and y coordinates of the vector. And so what we do is we go here and you draw it as a right triangle. So this is over 1, 2, 3, 4, 5, 6, 7, 8. And it's down 1, 2, 3, 4, 5, 6. So it's over 8, down 6. And you notice, and I'll throw the right triangle sign, that's going to be true regardless of the one we look at. You could go for B. Look at B. So we're going to 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And we're back right where we were starting. Because that's the transformation. It's over 8 is down 6. If you were just to do this with like, I don't know, just I'd say conversational English, you would say to yourself, okay, point A moves to the right 8 and it moves down 6. To the right 8 and down 6. Now on the Cartesian coordinate system, which is what the grid is called, named after René Descartes, we have a mathematical way to talk about going to the right 8. We say x increases by 8. And we got a way of saying it goes down by 6. We say that the y value decreases by 6. So here's the answer to the question of describing this transformation. There's two ways we're going to do it. One is we go xy. This is representing the initial point. So for point A, I'll just do one example. I don't need this anymore. For one example, point A is at 210. And so for point A, we have 210. All right, that's point A. Well, if I want all the x's to go over by 8, I write x plus 8. And if I want all the y's to go down by 6, I write y minus 6. And this is the answer. That's the description of this translation. But let me get you an example here. Let's holler out an example. So what I'm going to do is I'm going to say, okay, so let me put the arrow down because I don't want to run out of space. I don't want to run out of space. So what I'm going to do is I'm going to go 2 plus, now it's plus 8. Okay, so I'm going to go 2 plus 8 is equal to, and I'll 10. Okay. I'm going to go like this now. Changing my mind on the fly here. So 2 plus 8 is 10. Okay, so 2 plus 8 gets me to 10. And let's look at the y. I take away 6. So my initial y value is 10. So if I take away 6, I end up with 4, which is where I wanted it to be. And so you could do this as an example now. You say, okay, so this is 2 plus 8, comma 10 minus 6, which is 10, 4, which is right where I wanted it to be. And so we're over 8, down 6. Another way to write this, and I don't know if your teacher does this, we like to do this in my class, it's kind of a shorthand, is you put a sharp arrow. This is called vector notation. You just go positive 8 minus 6. And these two things mean exactly the same thing. So you either write it all out like this, or you do this quick shorthand. It says over 8, down 6. Now one other thing I need to show you, because I love matrix notation. I love to teach it, and when I'm doing transformations, I use it a lot because I feel like it's very readable. So let me throw this little extra piece out, and I think you'll like it. My students almost entirely use this, what I'm about ready to show you, even though I don't ask them to use it. So it must be useful. So here we go. We're going to go points A, B, C, and I'm going to list all, instead of listing them next to each other, X and Y, I'm going to list them, stack them vertically. So I'm going to have this as 210. I'm going to have this as B is negative 5, 7, and C is negative 4, 3. Put a little arrow. And the arrow is where you put your transformation. So we're going to go, all the x's are going to go up 8. All the y's are going to go down by what? 6. They're going to go down by 6. All right. So here we go. And this is why I like it, because I just do all the x's at once. So all the x's are moving over by 8. So that's going to give me 10. That's going to give me 3. And that's going to give me 4. And all the y's are going to go down by 6. So starting at 10, that's going to be 4, 1, and negative 3. And so these are your new points. And so, you know, this question really could have been phrased like this. I could have said, well, what is it? I don't know. You figure it out. And you got to ask yourself, what do I need to add to 2 to get to 8? And whatever you add to 2, what do I add to 2 to get to 10? And whatever that is, it should also bring negative 5 to 3. And that's called matrix notation. All right. So next problem, let's get one more. I want you to be able to hit pause. So let me just kind of set it up for you. And I graphed it, so I have to go grab my graph. But let's do this. I'm going to say point A. And this is the one I really want you to pause and see if you can't do it on your own. This is the coordinates of point A, 3, 9. B is at 6, 6. And C is at -1, 7. So that's going to be the pre-image before the transformation. After the transformation, I'll put that down here. A prime is going to be at 0, 5. B prime is going to be over there at 3, 2. Holler at 3, 2. And C prime is going to be at -4, 3. So the question to you is, describe the translation that takes a triangle ABC and maps it on top of A prime, B prime, and C prime. Hit pause and good luck. All right, let's unpause this. In fact, while I unpause, let me switch this real quick. Don't worry. Don't worry, I'm set up. Look at that. Look at that. That's unbelievable. That's unbelievable. Unbelievable. Okay. So the gauntlet was dropped, if you will. And let's see what it is. Well, first thing I'm going to do is you could graph it, and I could draw the vectors. So that's what you want to do, especially if it, like, say you didn't know it was a translation. I mean, I told you it was a translation, but what if it just said describe the transformation? So you can draw a line from the pre-image to the image, like so, from point B to B prime. And if those lines are all parallel and they are all the same length, then it's a translation. That's the calling card of a translation. Where's I had a triangle. Where the hell did it? Oh, there it is. All right, never mind. We good, we good. All right, boom, boom. Okay, so every single point travels the same distance in the same direction. Now we got to figure out how to best describe it. Well, you can't always describe it by its x and y coordinates. So C goes backwards 3 and goes down 4. And that's how you might describe this vector to somebody in a conversation. You might say, well, really what you got to do is you got to go back 3 and you go down 4 and you'll be right where you need to be. So how do we describe that in mathematical notation? You got to go back 3 and down 4. Well, it's like this. All right, so this is the solution to the question right here. X goes back 3 and Y goes down 4. And I introduced vector notation. You can bring it up to your teacher if they don't already use it, but so you could just describe it like this. Remember, these are sharp, meant to look like kind of arrowheads, not circular like that. So that's the answer, back 3, down 4. And Y, again, we'll assume maybe you didn't have a graph. Maybe you didn't want to graph it. I don't know. How could you figure this out? Well, you got to ask yourself, if I go from 3 to 0, I'm subtracting 3. Well, I have to be doing the exact same thing to B. So let's see. B goes from 6 to 3, which is subtracting 3. And C goes from -1 to -4, which is also subtracting 3. So I always subtract 3, meaning every single point goes to the left 3 units. And you could do the same thing with the Y's. Okay, so we look at our Y's and we go 9 to 5, that's a -4. We go 6 to 2, that's a -4. And I think you get the point. So you don't have to necessarily draw it. If you look at the points, you could just look to see, do they always change by the exact same amount? Do they always travel the exact same distance? And just because I can't help myself, and I'm hoping somebody puts a comment like, yo, I've started using this matrix notation, this is pretty sick. I'm gonna be pretty stoked on that. So I'm just gonna show you this notation. All right, so what we do is we stack the points so the x and y are vertical. And now when you apply the transformation, which let's apply this transformation, so all my x's are going to go down by 3. All my y's are going to go down by 4. Let's see what I got. I mean, I should get this, but we'll see. Down by 3, so 3 minus 3, that's 0. 3, negative 4. My y's all go down by 4, so that's 5, 2, and 3. So this will be my new points. And there it is. Last little thing I gotta say is that a translation is always an adding and subtracting thing. It ain't a multiplying thing. It's not a multiplying thing. So the rule is always going to be plus or minus some value. A rule for a translation will never be 2 times a value, something like that. It'll never be a multiplication thing because, and this is the last thing I want to say, look what happens if you multiply the numbers 4 by 3, you get to 12. So 4 increases by 8. Now if you multiply the number 2 by 3, you get 6. So the number 2 increases by 4. Those aren't the same. So multiplying, it wouldn't make every point travel the same distance. It's gotta be like this. It's gotta say, yo, every point go up 3, or like every point go down 3. You can't say double every point or triple every point because they won't all be moving the same distance. All right, one last thing I gotta say. Oh my gosh. Hold on. And it's conclusion time. All right. So I apologize if I seem distracted today. I'm really happy this song came on. I mean, I put it on, but I'm just glad to hear it. We start school tomorrow. We had a little over a week off. We're here in Northern California. We have some pretty horrendous fires. This school became an emergency evacuation zone. And so for the last week, the library, the whole small gym, big gym, all full of cots, people without any more homes, just needing some shelter. And so we get started tomorrow. And I think I did this because honestly, I don't know how to teach right now. Be real clear to you. I don't know what to say tomorrow. I don't know it at all. Just seems hard to get back into the groove of things. So to you I say, I assume you're in a safe place, and that makes me happy. When things like the tragedy strikes, sometimes it's like, oh yeah, I guess that's all that matters. I guess all that matters is you're healthy. You're in a good spot. So take care of yourself, be kind to each other, and this is how you do translations.